Hi, my name is 𝗧𝗏𝗂𝗏. I'm a NASA space scientist, and I want to talk to you very briefly about Nibiru. I'm doing this because I received a note from a 12-year-old girl recently that said she wondered if the video I made 2 years ago was still valid, that she and her classmates were scared about Nibiru, and could I please explain from a science point of view why we know Nibiru is not real and is not a danger. You know, the simplest thing to say is just that there is no credible evidence whatever for the existence of Nibiru. There are no pictures, there's no tracking, there's no astronomical observations. In fact, the origin of the name is a little weird. Nibiru was a minor god in the Babylonian pantheon, probably associated with Jupiter. There's no record that they ever thought of it as a planet. Sometimes we talk about planet X, but that's a strange term too, because astronomers say planet X for an object that has not been found, a possible object, like Pluto. When it was being searched for, it was called planet X. Once it was found, it became Pluto. So there really isn't any evidence here to counter, but I can quite specifically say how we know that Nibiru or planet X does not exist and does not threaten the Earth. First, if there were a planet headed into the inner solar system that was going to come close to the Earth in December of 2012, it would already be inside the orbit of Mars. It would be bright. It would be easily visible to the naked eye. If it were up there, you could see it. All of us could see it. And the crazy thing is people who say they are observing it but never tell us where to look so we can verify. Well, it doesn't take an astronomer to say that there's no bright object up there that's appeared in the night sky and is headed for Earth. Second, if Nibiru were real and it were a planet with a substantial mass, then it would already be perturbing the orbits of Mars and the Earth. We would see changes in those orbits due to this rogue object coming into the inner solar system. Astronomers measure the orbit of Earth and Mars precisely and frequently, and there has been no change whatever. Third, and perhaps most telling, if this object had come through the solar system in the past, and you remember the idea is it's on an orbit of 3,600 years. If it had come through in the past, its gravity would have messed up the orbits of the inner planets. The Earth, Venus, Mars, probably would have stripped the moon away completely. Instead, in the inner solar system, we see planets with stable orbits. We see the moon going around the Earth. The very existence of this stability in the inner solar system proves that no rogue planet, no interfering object has come through the inner solar system in at least 1 million years. So it's not real. Nibiru doesn't exist. We can't see it. We can't detect its gravity. And we don't see a signature of its previous passages because there weren't any. Now, some people change the story around and say, well, Nibiru isn't even a planet. It's a brown dwarf with planets going around it, or something like that. Everything I've said would be worse with a massive object like a brown dwarf. That would have been tracked by astronomers for a decade or more, and it would already have really affected planetary orbits. So please, get over it. Nibiru isn't real. Planet X isn't real. We don't have to worry about this hoax.
Look at the UK. We've had the hottest climate for 9 years, so it's not been as hot as this in a single day since 2006. According to my records, when I go back to 2007, you can see that things really started to change with regards to the northern region of our planet. And you know, on other videos I've showed you those changes with regards to Arctic coverage and snowfall. So, you know, we have a foreign minister saying some months ago now, you know, a few hundred days before climate chaos, what could it possibly mean? Well, you know, I'm just using my observations with regards to this. I mean, like I say, I'm just going to give you a little twirl around the Earth so you get an idea of just some of the temperatures, keeping in mind in that box there. You know, as we go around, even over the Pacific Ocean, you know, we're at 28 degrees. And something I want to bring to your attention in a minute is around the 30 degrees longitude and 60 degrees longitude, and you probably guessed it already why I'm talking about those longitudes is because that is where the polar jet stream resides and the subtropical jet stream resides. We'll pull up a little map in a minute so we can just get a better idea. Again, these two regions seem to be showing cooler you know, locations. Just look how if I just you know, get some temperature readings over this direction here, you'll see where I'm talking about. At 45 degrees north, you can see 35 degrees north there, we're at -4. And the reason why I'm showing you the temperatures in these regions, because like I say, they're around about 30 degrees, well, exactly 34 degrees north. But the reason why I'm showing you these temperatures is because I want to show you something on the North Pole right now. Now, we are at our maximum tilt, just coming out of 24 degrees, because we're in our summer over the Northern Hemisphere. But these regions, which I pointed out in a previous video, were showing signs of becoming cooler. And again, we're at 28 degrees. So now I know that along the Chile coast we've got some mountainous regions, but I don't think that this region here, this vast region, is covering just mountainous regions. I could be wrong. I've not looked at you know, the landscape in those areas, but I have noticed that these regions are becoming cooler. And I suggested that if we're getting magnetic pole migration, that maybe the new poles would form in cooler places where it favoured stronger magnetic fields. Now, if there's a molten core and there are cold spots on the crust, maybe that will encourage the development of stronger magnetic material to build up in those locations. So that's why I brought that to your attention. So let's have a look at the temperature then over the Northern Hemisphere right now. Let's get it over the Arctic region and just start pulling up some random temperatures. So we're at 1 degrees there, just under half a degrees there, 0.4, 0.1, 0.4. A nice minus temperature there, so that's good, but I would expect that overland in any case. A nice -6 there, 1.1, 0.1, 0.1 again. But the point is this, is that that's the Arctic region of the Earth, and we're seeing colder temperatures on this particular part of the Earth here, -5, and it's a northerly location. Bear that in mind. The other thing to note is, have a look at the Northern Hemisphere right now. We're looking right down on it over the Arctic region. Can you see a polar jet stream? Can you see a prominent thermocline where the temperature jumps from sub-zero temperatures to just above sub-zero temperatures? You can't. Now, my point here is, have we lost a polar jet stream on the Northern Hemisphere right now? And is this leading to this heating? I mean, you can just see by looking down over the Northern Hemisphere. If I just start tapping in some temperatures, we're at 25 degrees there, and I'm just going to come round quickly. Just keep your eye on the temperatures as I go around these locations, and you'll see they're mostly above 20 degrees or more. And to get, to have an area northerly, region such as this point here at -6, when you've got an Arctic region here at just over 1 degrees, something doesn't seem to be adding up. Now, I talked about jet streams. Now, if I just go over to the southern hemisphere, we're going to see a totally different story here. It seems to be holding its polar jet stream, because we're at 60 degrees here, just or around about. If I just make a few temperature inquiries around that area, we can see we're around about 60 degrees, which is where we would expect to see our polar jet stream, but we can see a prominent thermocline, and that is, when I choose a zone like this, we're at -1.6 and go into the green, we get a change of temperature, and you can see it visually anyhow. The blue goes to green. But on the northern, I'll just for argument's sake, I want to show you what the temperature is in the Arctic region, Antarctic region, -67, right? Something very strange. We don't get those temperatures in the Arctic region ever, that low, and we can see a big difference. But bear in mind, we are at a 24 degrees tilt, or just leaning out of that. I could check the exact records, but we're just trying to establish some variables so we can see what's happening. But a different picture again, no visible thermocline other than this busted jet stream, I would say. I don't think there is a jet stream, a polar jet stream right now over the northern hemisphere. Now, is that due to magnetic pole migration? As you know, I believe so. But just to reiterate this, let's have a look at where the polar jet stream should be. So, just quickly, we can see that the region where the polar jet stream should be is 60 degrees north and 60 degrees south. The subtropical jet stream should be 30 degrees north and again 30 degrees south, and we can see where they are in conjunction with the equator and the North Pole. So if we go back to our map, we should see whether they're in the places they should be. So what we can see is where the marker is taking a temperature sample, we can see that it's around 60 degrees south, and that is where a polar jet stream should be. And we see the variation in the colour of the temperature, indicating to us that there is a thermocline there, and therefore we are most certainly probably looking at the Antarctic polar jet stream. And we could go pretty much all around the vicinity of that, taking samples all around that edge of that thermocline, and we would be around about 60 degrees, give or take a few. So I'm happy with that. I would say yes, we've still got over the Antarctic region where it should be, a polar jet stream, but it's different when we go north of the globe. And we look down, and I'm just going to I'm going to say that the bluer area is the thermocline, right? But if there is a jet stream there, it should be around 60 degrees, and I'm going to take some readings. 71 degrees, 73 degrees, 74 degrees, 78 degrees north, 69 degrees, 69 degrees, 82 degrees, 77 degrees. I'm going to take a reading there as well. 66 degrees. It's not prominent at all like the southern hemisphere of our Earth, is it? So maybe this is what they're talking about when they're saying climate extreme or climate chaos, especially when at 30 degrees north, or 35 degrees north as is the case here, we are getting probably temperatures that would more suit the Arctic region than you know, that region there. And that's, you know, I think you know, and the reason that all this region here is quite cool compared to the region on the other side of the Earth at that 53 degrees. Let's see if we can get 53 degrees over here as well. Almost proves the fact, you know, we're at 51 degrees, that'll do. Right, but look at the temperature, 19 degrees over that side, and at 50 degrees or thereabouts this side. Okay, 53 degrees, we're at 2.8 degrees Celsius. There's something changing, isn't there? And yes, we know that the magnetic North Pole is migrating in this region, and I have suggested that it will be taking the Arctic region and climate with it, and it seems to be looking that way. But this is what surprised me when I started to see, you know, these temperatures forming in this region. I mean, in some places in this region earlier on, I was getting colder temperatures than what we were getting over the Arctic Circle, and that's at a 30 degree, you know, north, when, you know, it should be, those temperatures should be at 60 degrees north. So there is definitely, you know, climate chaos taking place. You know, there is, you know, very cold regions of this Earth in unusual positions with regards to that, and it just so happens that what these two regions are the same distance as what the Arctic Circle is to the Antarctic. You know, it's 12,000 miles from this region here to, you know, that region on the other side of the world, where we're also seeing at you know, 25 degrees, you know, 30 degrees. So 30 degrees south of the equator, 30 degrees north of the equator, we're getting sub-zero temperatures, and persistently, because as you've been following the videos, you've seen that these regions have been cold for that period of time. So this could be supporting the theory a little bit more, that not only is the magnetic pole tracking on a vector easterly towards Siberia, but it's also taking the climate with it. Not only that, these two regions that we've recently been following for some time now here, and the one over in Chile, that show sub-zero temperatures, you know, at a time where even the Arctic region isn't showing them, could be considered climate chaos. And, you know, it's just has been unheard of for us to get this sort of temperature for quite some time here in the UK, and believe me, it's been really uncomfortable, especially when I think our bodies adapt to a cooler climate, and then all of a sudden we have, you know, a few days where it goes wild like this. It's the only other time I've felt that sort of heat is when I was in the Caribbean, literally when I walked out the apartment door and that oven heat hit you as soon as you left there, and it's been almost unbearable. There's no aircon in pretty much most of the properties in the UK, so, you know, I'm not the only one that's going to be feeling it, but it's due to change, and that's the reason why I did this video today, just to show you these temperatures that we've been having around the northern hemisphere of the Earth. The last video, the last clip on this video that I want to show you is just a little bit further out into the atmosphere. So we're going to back out the millibars so that we get a higher altitude look at temperature to see what sort of things we're viewing, because I believe the subtropical jet stream is more brought out in that region of the atmosphere, and we get an idea as to what that looks like now. And I think, you know, they seem almost intact. But let's have a look at them. Let's have a look at the subtropical subtropical jet streams. So guys, I've backed it out, so we're looking at a region of the Earth a little bit higher in the atmosphere, and it brings out the trend in the subtropical jet streams, and those would be normally at 30 degrees. As you can see, well, you can't because I've just got it on the map, but we're at 51 degrees there, 43, so we're coming down, 38, 37, 33 and 29. So around this region here, and I suppose this region here, is where the subtropical jet streams are, and you can see by the thermic line, the change in colour on the map from green to blue is roughly where our jet streams are. And you can see why, when you look at this map here, this weather system pushing up on the jet stream as it's bending right over the UK is probably a good reason as for why we've been getting the the subtropical weather as what we have over the last few days, which just really sent the temperature right up. Cyclical event there, well worth keeping our eye on. See whether that develops into perhaps a mid-Atlantic or North Atlantic hurricane. We'll see. It's unusual, but still well worth a look. And it gives, like I say, this just gives you an idea of what those subtropical jet streams are looking like. And you've got to notice it. They are yondering up into where the polar jet stream should be. You can see it on more than one incident on the map. 62 degrees here, again a subtropical jet stream going up that far north. This is what causes these freak weather systems that we get. And again here, 65 degrees north, and then the jet stream leans down to 49, goes over to 63 degrees north again, and I believe even a little bit higher over here, 71 degrees north. So we're probably seeing a mixing of subtropical and polar jet streams over the northern hemisphere, considering when we start looking at the regions here, 30 degrees, exactly where it should be, 27 degrees, 33 degrees, slight deviation there, 22 degrees, 28 degrees, 28 degrees, 29 degrees, 31 degrees safe. So the southern jet stream, subtropical jet stream, seems to be where it should be. The northern jet stream much further north than what it should be, and it's a surprise we don't have a defined polar jet stream right now on this planet. And if you look at the Antarctic region, we see something a little odd here as well. Over one end of the Earth we've got temperatures of minus 54 degrees here, and over this side temperatures of minus 22. Big fluctuation in between the two. So I'm going to round it off here, guys. You might be wondering how we're getting on with the magnetic station that we're building, the magnetometer station that we're building. Well, we've got another sensor, the FMG3 sensor, which is going to be measuring the magnetosphere for us. There's another magnetometer being ordered. There's a few more transceivers being ordered, so that we've got the 4 transceivers connected to the sensors that will be communicating with the the master in the house, whilst all those are outside communicating with the master wirelessly. I feel like I'm in a dark room with a candle with regards to the programming on that. I have pursued another avenue with regards to a program and a library, which I'm just struggling on getting the one library working now. If I can get the data being transmitted back. There's not a problem here. I mean, we've moved to the point where we've got these transceivers communicating with multiple transceivers. We just need to be sending the data from the magnetometers back to the gateway, if you want, so that we can put that back into Python, or we can send it to a data logger off the Arduino and then compile the data in Excel or something like that, just by using a flash drive or something like that. Well, that's where we are with that. I'm still working on it. I'm not giving up. If there's anyone out there that is more familiar with programming Arduinos and libraries out there, and they would like to throw a hand out, then that would be more than welcome. I mean, I really do feel like I'm out my depth with this stuff, but it's not putting me off progressing with it. I want to get that station built. I would have loved to have already had it finished. It's putting these things in the casing, getting all that bit, that's my niche. I can build those devices and build them good as well. It's programming, unfortunately. We're not good at everything, and like I said in one of those videos, I do feel like I'm the manager of the hotel, the cook of the hotel, the porter of the hotel, the pool cleaner, etc, 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 and it's you're inevitably going to run up against the problem, and I have here, but it's not put me off. I mean, I've not progressed in that I've moved forward with the project, but I have with learning a lot about programming and Arduinos and libraries and other electronics. And because I'm starting from scratch, really, it's not. I've had a go with I have messed about with very light electronics before, but nothing as in depth as these that require not just assembling them. I wish it was the case. More plug and play. It is going that way, but I wish it was the case right now, because I'd have had this finished by now. We would have been having data to look at. But it's just the way it is, guys. Again, if there's someone out there that's a bit more fluent in Arduino programming and feels that the course is well worth it, at the end of the day, what we're trying to do is get an early warning system for when the pole starts to get into those weak field lines and migrate really quick. That's what it's about. It's about informing people. So get in touch if you can program, and we'll get things moving a lot more quicker. Link down there if you want to support the channel and its research. A big thanks to Dave and Melissa, who made a very unexpected contribution towards the channel. It's great meeting up with you guys as well, and I hope it's not the last time. If ever you're in the UK again and want to drop in, then just give me a bell. It went very quickly, our meeting with Dave and Melissa from New Zealand, and I both feel, me and my wife both feel that we could have continued with that conversation forever. It was just a shame that time ran out and they had to move on, but big thanks to you guys. It is massively appreciated, and it's good to have people on our wavelength that feel that the research is well worth it. So, having said that, guys, I'm going to leave you alone. I hope I haven't kept you more than what I should have done. Stay tuned. I'm sure it won't be in the not too distant future. We'll be getting some data back out of these magnetometers, and it'll be worthwhile watching the magnetic pole migrate across the northern hemisphere, and hopefully we can process that data in a simple manner where people can see on a map, just simply like what we're looking at here, where the magnetic North Pole is today and where it was a month ago or a week ago or 5 months ago or even 100